I'm going to talk about the mission-specific platform facilities and scientific measurements. And as we learned in the previous talks, our expedition consists of two phases with also two different settings. So we do have the offshore phase where we are somewhere on the water, and we do have the onshore phase where we are on land in Germany, in Bremen, in the MARUM building. And I will start now with the offshore phase. And as we learned, we can use several platforms, and sometimes we can also use research vessels. And if we have research vessels, they also do have a lab infrastructure on board, so we can use those labs. But if no labs are available, we can bring our own labs in containers. And I'm showing you now some example of our containerized labs. This is an example of the curation container. So I'm one of the offshore curators. So that's where I will spend a lot of time during an expedition. And in the picture, in the upper picture, you can see the two brand new lab containers we have here. And they are offshore containers, so they ensure a very safe work environment on the vessel. And if you have a look at the picture on the left, you can see how the container looks like before an expedition. So when it's still sparkling clean and not messed up at all. So please remind that picture. It will change during the expedition. And what you can see in the scheme is that we do have a lot of space for co-curation in there. So we can do the co-curation according to IODP standards. All our lab containers do have air condition so that we can work in cold or hot areas, but we will always have a stable temperature inside our containers. And on the other side of the container, there's a chemistry bench where we can do more or less the dirty work for the geochemistry. And yeah, the next container is the geochemistry container, where we do have more space for the geochemistry stuff. For example, the sample preparation, pore water splitting, or some analytics. We do have a freezer in there. There is space for a gas chromatograph, and very important, there is a fume cupboard. So whenever we have to work with chemicals, we do that under the fume cupboard, and we can produce our own molecule water. So we always have pure water on board. And yeah, there are more containers, lab containers offshore. You've already seen the MSCL container. So that's the container we use for the physical properties. We also have a science container. That's where there is a sedimentology and paleontology lab inside, where we put up the microscope, and there's also office space inside. And we can also bring our microbiology container if that one is required. This container can run with 4 degrees Celsius, so it's also a cool lab and a clean space. We can put up some glove boxes in it. There is a fume hood, and there is also space for -80-degree freezer in it. So everything you need for microbiology. There are more containers for the drilling operations and also for data management. And there are also reefer containers where we store our core in the end. And on that picture, you can see an example how we would like to set up our containers so that the doors are facing one street, which is then called the main street or the science alley or science garden. So there are several names. And in that case, the street was covered because it was a rainy season. And the next picture shows the main street during night. And that was close to Christmas, so we put up some Christmas lights. So if some people may think that working in containers isn't that comfortable, but it's actually quite cozy. And it's at the back of the ship. It's very close to the water, and it's like a little village where you actually you can go to work in the morning. So you leave the ship and go to the container village in the back. Okay, that was about the facilities offshore. Now I'm going to talk about the sampling offshore. And like we have heard before, the cores will not be split offshore. So they will stay as they are on that picture. As whole round, they won't be splitted because we just don't have the manpower and space offshore to split them. But what, as you can see in that happy face, that doesn't matter because we take care that all the necessary samples and all the data is collected and saved offshore for the later analysis onshore. So no data is actually getting lost. And on the left side, you can see the core sections. And when we do get a long core, we will cut it down into smaller segments. And on every segment, we do get a fresh core surface. And that's where we actually can take some samples. And we can also take pore water samples offshore. And we can sample the core catcher. The core catcher sits in the shoe of the core and it comes without a liner. And sometimes it's an intact sample, sometimes it's a bag or muddy sample, mushy sample. And it's always easy to access and it's always representative for the depth. So the core catcher can be sampled offshore for sedimentology or micropaleontology, for example, for forams, if you're interested in the ages. All right, just to make the sampling offshore a little bit clearer, I will show you the core flow offshore. So first we do have the core on deck, then we do the core sectioning in the smaller sections, and that's where we get our fresh core surface. That's where we can do the headspace sampling for methane, for example. We can do temperature measurements. We also did penetrometer measurements with a horizontal handhold penetrometer in there. And then the cores will be transported into the containers. First, the curation container. So that's where the cores will be cleaned. They will be kept. They will be measured. They will be labeled and engraved, and everything will be entered into the database. So everything happens according to IODP standards. And if the curation is finished, we can start with the pore water sampling. On that picture, you can see the pore water sampling with rhizins. So we insert a small filter into the core, and with under pressure in the syringe, we can suck out the pore water from the core. If that step is done, the cores can go into the MSCL container for the physical properties. If those are measured, the core can actually go into the science container where they do the core description. And even that is possible through the liner because we can see color changes and we can see changes in the lithology. So if it's sandy or muddy, and this is already very useful information. If the core description is done, the cores will be stored at 4 degrees in one of the reefers. All right, about the measurements and analysis offshore. So very important is the conservation and fixation of all sensible samples, especially for the pore water. And we also do subsampling for the shipboard data and also for requested data. About the pore water, so we can sample it with the rhizins and also with hydraulic press. You can see in that picture over there. And we analyze, or we do the ephemeral measurements offshore, that is salinity, alkalinity, and ammonium. And here you see a scientist doing salinity measurements with a refractometer. We can also analyze the sediment samples, like I mentioned before, from the core catcher. We can analyze microfossils like forams, nanos, diatoms, or prepare smear slides and analyze those with the microscopes you can see in the lower pictures. If you are interested in a chemical zonation of the core. We can also analyze methane and sulfide offshore, and further microbiology analyses are also possible if they are required. All right, so summing up the offshore facilities and measurements. So we do have a very modular container or lab setting for the expeditions. We can use the labs in the vessel, or we just bring our containerized labs. We have a high flexibility for methods and devices. We just need to know in advance what is required. And all the cores and all the samples are saved for the later analysis onshore, so no data is lost and all the necessary work can be achieved offshore. All right, so now we are switching to the onshore phase, and that's where I am sitting right now at the MARUM, at the Center for Marine and Environmental Sciences at the University of Bremen. So this is an internationally recognized center for marine research, and it's a relatively young research center with an excellent lab infrastructure. And here on those pictures, you can see 4 examples of the labs we are using for the onshore phase. The first picture shows the core description lab. The second picture shows geochemistry lab. The third picture is our big sampling lab, so where all of the magic is happening. And the fourth picture is showing the XRF lab, where we also can do line scanning or core imaging. And not to forget, we do have the IODP Bremen core repository over here, where we store 158 kilometers of core from over 90 expeditions. All right, now we're coming to the onshore sampling party. That is the name for the onshore phase, where finally all the scientists can meet each other and where the cores will be split. They will be split into the archive half and the working half. And the the archive half will be used for the destructive measurements. Here you can see preparations for a line scan. So the core is not touched or no sampling is done on the archive half. And you can see an example of a very high resolution core image at the bottom of the slide. And the working half is there for sampling, like you can see in that picture. All right, and now I'm going to give you 2 examples about each half. So first about the archive half. Here we are in the core description lab, where you can see two scientists describing the core. And maybe you remember the other picture from the previous slide, where we show the core image at the top of the core wall system. So these are these big screens. And at the top, we do have the core image, and below we have the physical properties. So if the data is already available, if we or analyze those parameters before the onshore party, they can be used for the visual core description, which is quite helpful. And if we don't have the data, we can use the core wall also as a big zoom in into the core, which is quite helpful for the scientists if they want to show something to their colleagues or want to discuss something, and they don't have to look through the small lenses all the time. And now we're going into the lab next door, which is the big sampling lab, where the working half is sampled, and it's sampled for the shipboard data, but sampling for post-cruise science is also possible during the onshore science party. On the left picture, you can see a high resolution sampling, where they sampled for diatoms in the wharf sediments. And in picture number 2, you can see that we also sample hard rock. So we do have a saw and we do have a drill available. And we also do have a lot of fun in the sampling lab when we start with the sampling of the cores. All right. Now about the typical measurements and analyses we can do here at the MARUM. So the physical properties will be covered with non-destructive parameters as well as with discrete samples, for example, moisture and density. Micropaleontology will be covered with forams, diatoms, nanos, pollen, so with palynology. Sedimentology can be done with core description, thin sections, smear slides, and so on. Paleomagnetic measurements will be done, and geochemistry is also covered with the pore water. So, for example, the samples from offshore, the cations and anions, and also the solid phase can be analyzed with XRD measurements. Additional measurements are also possible outside IODP standards, so they are possible by special arrangements here with our colleagues at the MARUM. But for that, I would like to ask you to just check out the MARUM website to see what's actually available, so what labs and what analyses are possible. All right, so summing up the onshore facilities and measurements, one of the highlights is definitely that all the members of the science party can finally meet at the OSP. And that's where the joint extensive description of all the expedition cores will take place. And sampling for your own scientist post-cruise projects is also possible. And another advantage is the excellent lab infrastructure under optimal conditions. So we're not on a moving ship here. We're under stable conditions, and so nobody can get seasick. That's quite important if you sit at the microscope. All right, so back to the slide from the beginning where I was talking about the two different settings and two phases. And as Dave and the other mentioned before, there is kind of another phase in between the offshore and the onshore part. And that is the time the container needs to transit from the offshore or from the harbor back to Germany, to Bremen. And this adds up 2 to 3 months extra time. And that's really a useful time because you have a lot of time to review the offshore data, also the logging data. And yeah, you can talk about a nice sampling strategy for the OSP. And you can also do additional shipboard measurements in that time if they are required. For example, what was previously done was CT scans or thin sections, PAL samples for dating, so that you actually know the age of the sediments before you start with the sampling. So I think that is also a big advantage of our expedition setup. Yes, that was it from me, from the facilities and scientific measurements. And yes, if you do have any questions, please ask.
Thank you, Patrizia. That was excellent. Nice slides. Okay, any questions in the chat? Yes, here's one from Rachel. So, Patrizia, you showed some X-ray CT scanned core images in the presentations. Are there facilities or support for these in the core repositories?
So we don't have a CT scanner here at the MARUM. Was that a question?
Yes.
I'm sorry if I got
Yeah,
that right. Yes, we don't have one available here, but if that is required, previously we also organized something after the Chicxulub expedition. So that can be organized, but it's not part of our facilities here.
Yeah, so this comes back to Patricia's point at the end of our presentation there, that there's this time between the two phases that can be used for these additional analysis. And the Chicxulub example is a great example, and it was actually something that was driven by the co-chiefs and facilitated by ESO, that the cores were going to be scanned in America on their way back from Mexico. So they went from Mexico to the US, CT scanning was done there, using state-of-the-art facilities, and then the cores were transported to Bremen. So the third-party institutes and facilities can be used to do something with the cores as they move from the ship back to Bremen, and that was exactly what was done with Chicxulub, and it worked really well. Superb high-quality data that was available ahead of the onshore science party, so people could digest the information and data and try and work out what it was telling them before they even arrived in Bremen. So there was lots of discussions going on about what the data was saying, even before people set foot in the repository. So again, it's something for proponents to think about. It doesn't have to be CT scanning. Maybe it could be some new analysis that we're not aware of at some new facility that they have access to. Please think when you're formulating your proposals, what extra steps you might be able to insert into the standard MSP procedures to make more of that few months time between the offshore and the onshore phase.